Hello. Uh, as Alexei said, my name is Oskar Dudycz, and today I'll be talking about Project France and what we managed to achieve in that. So with Project France, this year annual contest, so #1 prize for the worst event sourcing system. And let me tell you how we did that. So I didn't do it by myself. What's the single man without the team? So let me introduce our core members of our team. So at first we have Catherine. Catherine is our product manager. Maurice, head of development, and Roy, head of developers operations. Michael is our CEO. Donny is head of our accounting and legal and compliance, and Jordan is head of sales. And we also have the streaming team dedicated because we will be crossing a lot of streams. And this is me, as you noticed, because it appeared that to build the worst event sourcing system, you need to know how to build event sourcing system, because what we would like to avoid is to even accidentally create something that could be called good enough system. So my experience with event sourcing is spanning with over 5 years. I'm co-maintainer of Martin, which is a .NET framework that allows to use Postgres as event store. And I'm also working as a developer advocate at EventStore, where we are creating EventStore DB, so database dedicated for storing events. But that's all about me. Let's have a look on the competitors, because as this is a really serious competition, so we had quite known competitors. We had the smaller ones, we had like the creative ones, and we had weird ones. And we also had even the biggest cloud providers like Amazon. They also started in the competition, but we won that. So let's start with our first idea. So how did we start to build the worst event sourcing system? So this is our architecture diagram. I think that it looks blurry enough, even though it's just showing how to run the basic requests like getting data and storing the new state. So which is great, because remember, what's the worst is the good for us, and what's good is bad for us because we are building the worst system. So let me just go quickly through this architecture. So at first, if someone tries to get the data, then classically, we are trying to get data from the relational database, for example, listing users. After user makes some action, like updating, creating, or deleting user, then the request is handled by the service. And after that, new event is published. Because in event sourcing, as you know, the result of the business operation should be event. And here comes our centerpiece of our the worst first idea. So Kafka or other streaming systems like Kinesis, Event Grid, Event Bridge, etc. There are many ways how to break that down. So after we handled the comment, we are not storing the result directly in a database, but we are publishing that into Kafka. And after that, we have our event handlers in our service, and that are triggered by the event. And then finally, we are storing the new state into the database. So if that doesn't look for you so bad, so if you wouldn't agree that this is a good idea for a bad event sourcing system, then let's have a look in details on our scenarios. So
Oskar, can I?
Yep.
Can you remove this banner that crosses the title of the slide? I just got it in the chat.
Sorry.
Thank you very much.
So let's go with the eventual consistency. So we have simple scenario. We have 3 comments coming sequentially. So record inflow. Then at first we are trying to record that we get $100 from our auntie, and then we are getting withdrawals, 2 withdrawals with also for $100. So let's start with recording inflow. So we are processing the command. After that, we are storing the state, publishing event into our messaging system. Then we are handling it with the event handler, and we are storing information, so new account balance in our database. So far, so good. After that, we are getting a request to withdraw cash. And again, we are running business logic, checking the state. We see that we have $100, so we can withdraw the money. So we are publishing next event. After that, we are handling it and reducing the balance by $100. In the end, we are processing the final request. We get the current state. We see that this is not possible. And okay, and that looks good. And in fact, if that was the case in all the requests, then that would be in fact good. But with the messaging system, you typically have an eventual consistency. So when we are recording inflow, then after that we are increasing the account balance. But it might happen that when we processing withdrawals, and if we are getting the current state, then we might accept one or even more than one upcoming request. So we might end up with having the delay on queue. Our event handler might not be available. So we might have stacked the upcoming requests, and we might be validating them against the stale state. And after that, when we try to process in the event handlers these events, then it might appear that first one will decrease the state and the second one will fail. However, this is too late because we already got the money. So this is the eventual inconsistency that we would like to have in our system. So we would like to have from time to time stale data that we are validating our command handling, so to get wrong state and wrong operations. The next case is idempotency. It's crucial to not spell it wrongly. And let's start with the same example. We are recording inflow. As we don't have much validation, you can always add more money. Then this is the same case. But it might appear that because of retries, because service didn't return the response to messaging system in a certain time, we handled our inflow twice. So instead having $100, we have $200. And then we are processing our withdrawals. And because we have already $200 registered, then we can have those two withdrawals. So again, bank is losing money. This lucky guy is earning $100. So this is a good scenario for a really bad event sourcing system. Next, event ordering. As we know from the movies or even from the real life, it's sometimes hard to say what's the order of events that are happening. What year is that even? And let's have a look on an example of the department store. So as you see, a lot is going on here. So let's just blur the screen to make it more clear. So if you have a look on those bright rectangles, then they are representing separate cash register queues. And in each of them, we know precisely who will be handled because people will be handled one after another. But let's think whether we know if the lady at the bottom will be handled earlier than the guy in the middle or the guy at the top. We don't know. The rule with the cash register queues is that the slowest one is the one that we are standing. But joking aside, we can only maintain order within the single queue. And that's precisely how Kafka and other messaging system works. So in Kafka, you have the basic split is topic, which is the logical representation. For example, we might say that in this topic, we have all the events for users. And we might decide that in specific partition, we will store events for the specific user. So one partition, one stream, one entity. And that's also great for our case, because in Kafka, you can have at most 200,000 partitions. And as we design our system to be high load, high traffic, then having maximum number of 200 records is not great. Of course, we can juggle that and, for example, put a single topic and single queue and get global ordering. But then again, we are limiting our traffic and throughput. But we could handle that by the process managers. So by our business logic. So if we had the scenario where we see in the event handler that we already don't have enough money to be withdrawn, then in theory, we could try to perform a corrective operation. So if it's not withdrawn, but like a typical transfer between one account to another, then that's doable. But if someone already withdrawn money, then how you would solve that? And process managers, Chris already told today that they are not so hard if you do it right. But again, from my experience, most of the people are not doing it right. And especially if we are using process managers instead of basic rules for the consistency of our write model, then this is no-go for the good system. But for us, this is great because we will be adding more complexity and more process into that to reduce the failures in our system. So we will be handling the issues of our technical design by the business logic. So, and this is what you can see is not even a complex process manager. So that was a great idea because we had eventual inconsistency, idempotency, even disordering. But then, unfortunately, Donny called me and say, "Hey, Oskar, we have a problem," because it appeared that this is not event sourcing, but event streaming. And Donny read the papers, and it appeared that to win the #1 prize for the worst event sourcing system, we have to use event sourcing. But this is not bad because we wasted like 1 year working on that design, and wasting so much time, I think, gave us also the benefit and pros into the election of being the worst because we wasted a lot of time. So let's just briefly explain what's event sourcing. So event sourcing, when we are receiving comment, then we are getting the current state. But contrary to the common approach, like a relational databases, we are getting the state by the sequence of events. So for example, for shopping cart, that might be shopping cart initiated, shopping cart added, shopping cart, product item added, product item removed. And after that, after we got all of those events from event store, because as you see on the picture, event stores are in fact databases, not messaging platforms, then we are applying each of these events one after another in order of appearance to build the local representation of the state, usually in memory. And once we have it, then we can run the business logic and store a new fact about our system. So for example, that we removed a t-shirt from our shopping cart. And after that, the state is consistent. We can store events as JSON. We can store them as we are doing that in Martin in a relational table. So if you are doing that, then you have the same consistency guarantees as the traditional database. Or we can store it as a binary, like on a disk storage, because databases underneath are storing everything as the files on the file storage. And that's precisely what Event Store is doing, because as I mentioned, Event Store is database created for storing events. Having that, majority of event stores, or even all event stores that I know, can handle optimistic concurrency. What's optimistic concurrency? It's a, again, technique from keeping our state consistent and making sure that we are making our decision based on the latest state. So if we see we have the event store in the middle, then there are two upcoming requests. both of them are to get the withdrawn money. And both of those requests will get the same set of events because they are more or less at the same time. So when the first one, the lucky guy, will try to withdraw the money, then we will be sending the version, so that's usually aligned with the number of events, the version or position, together with the request to EventStore. And EventStore will verify whether version of the stream is the same as it is in EventStore. And if it's fine, so as in this example, we have version 3 sent in request and version 3 in EventStore, then it's good. We will be having new event registered, guy will get the money. And the second one will send the version that he got on the first request, so the number of events it got, and try to store a new event. But then EventStore will show that the version do not match and won't allow to append new event. So unfortunately for us, for our idea to build the worst event sourcing system, EventStore DB usually guarantees strong consistency on writes. So they are quite rock solid, which is a pity because we need to try harder to build really bad event sourcing system. So I forgot. I didn't tell you what's the Project France all about from the business perspective. Remember Jordan? Jordan is a specialist of human relations. As you see, he quickly can find friends, especially business friends. So let me explain you the Jordan idea, how to get the money for our system. Because being the worst, it's quite easy. When the system is not working, you are not getting money, you will quickly bankrupt. But being the worst means, in my opinion, something that is continuing and is just pure misery. So we decided that we will go as Uber. So we will get no profit. We will get some incomes. We will have some productions, but no profit. That's a perfect model for us to be called the worst event sourcing system. Of course, we said that we will be something like a Salesforce, so SaaS, because we will be greenfield. The easiest is to build something on greenfield because we don't know the business, so it's easy to make mistakes. And of course, we need to somehow justify that we will be using event sourcing. So we will be something like Revolut, so banking industry. It sounds like a good match for event sourcing. And we will be using all the fancy technologies, all the cloud providers, but we will also use on-premises because we need to make stuff as hard as possible. So we will be building our own event store. We won't be using any already created, and we will be hosting that on premise. We will tell that this is because of compliance, and the rest of the infrastructure will be on cloud. And of course, we will tell that we are supporting distributed ledger, blockchain. We will put some ifs and call it machine learning, and that will give us a time bomb. So we will get funding, and we will get time to waste. So at the end, it appears that we just created the worst system. And of course, all of those ideas, if they are sold properly to business, will give us money. So the money to waste upon. And this is Maurice. Maurice is head of our development. And let's talk about the overall architecture and decision that we made. Of course, we are using all the most complicated patterns like so-called clean architecture, or I should say onion architecture, not only because of the number of layers, but also from the specific smell. I think that even creator of this image don't know what's all about. I don't, which is great because that's what we want to achieve. So developers will be confused and trying to create layer after layer. And of course, we understand CAP theorem. So you cannot have everything. So you cannot have 100% consistency, 100% availability, and tolerance for the network partitioning. So as I mentioned, we have strong consistency on our write models, but it appears that it's not correct for the read models, because if we would like to create a distributed environment, and as I mentioned, that's something what we aim for, then we need to make our read models eventual consistent. So that's a good part of making our system confusing. I'm not telling that eventual consistency is bad. If you're handling that properly, then it's okay and it's needed, as it's in CAP theorem, but it's also a chance to have a lot of mishaps if it's done wrong. So, for example, why Kafka is having this partitioning and eventual consistency? It's not that because someone tried to create like a wrong system. It's perfectly fine for messaging, from moving event from one place to another, to synchronizing data storages. It's really fine. So if we are limiting consistency, then we are getting higher availability. And if we are doing adding more nodes, then we are getting higher fault tolerance. So it's all about trade-offs, but trade-offs are great because we can change wrong trade-offs in our systems. Remember the eventual inconsistency? As I said, it's always a trade-off. If we want to get quickly money, data, then sometimes it's fine to get wrong data, like in Facebook. If you are scrolling through your wall, then you don't care if it's all the messages that were posted. And events ordering, that's also about getting data processed the fastest as possible. So we can have a trade-off that we can put, as I mentioned, everything in one topic, one partition, but then we will lose performance and we will lose the scalability. If we are partitioning more and more, then we are getting higher throughput. So again, it's about trade-offs. Remember network partitioning? We would like to make a Roy's life pure torment. So he will be responsible for authentication and synchronizing and maintaining these weird databases that we created and synchronizing that with the cloud. And let's just stop for now and discuss delivery guarantees. So this is the exactly once delivery scenario. So we are storing the state in database, that might be relational database, that might be event store, and then we are forwarding it through some messaging platform to the other microservice that will keep also the local state based on the workload that was triggered by this event. And in fact, exactly once delivery is not totally possible. So because if we are managed to store data in our local storage, then after that, our publishing may fail. For example, messaging platform is down, and if someone's telling that, yeah, but those platforms are highly reliable, but remember the Facebook drop down like 2 days ago? Yeah, so even those messaging platforms that are highly fault tolerant might fail. There might be some transient error. Network packet might be dropped. And the same case is for when we manage to send that to messaging platform. And also messaging platform might go down, might have total Byzantium failure, and data might be lost. Even Kafka is much more reliable on that, but there are platforms like Zero, MQ, etc., that you can just lose the data. And then messaging platforms might have issues with delivering the message because service might go down, might misbehave, network packages might be dropped again, and the internal logic might be also wrong. We might have bug, database is not available. So that's why exactly delivery is almost impossible. What's real, it's at least once delivery. So we will get the message one or more. And that's why we are getting idempotency. So because of the retries, in each step of this failure, we need to make sure that we are retrying all of those failures to have fault-tolerant system. And because of the retries, we might get events more than once. And again, this is a briefly explanation of CAP theorem, and we are totally understanding that, but still we will be going with the CRAP theorem. So even though we understand that this is not possible, then we will demand from our development team 100% consistency, 100% availability, and 100% tolerance for network partitioning. So we will be just eating popcorns and seeing how they are trying to patch all of that stuff. Because if we, as I mentioned, if we have a look on the specific issue, then that's something that is trade-off and can be a good thing. But if we stack all of those issues and demand everything, then that's a recipe for the worst system and, for example, the worst event sourcing system. So that's something what we would like to achieve. And a lot of the stuff that I mentioned about even around CAP theorem could be solved by discussing with business. Because it might appear that if we discuss issue with business and we ask whether we really need this strong consistency, and if we cannot just solve it differently, then it might appear that business will tell us, yeah, okay, let's do it differently. Or maybe they will accept some eventual consistency, some delay in processing, because the real business systems and processes works like that. Like, for example, if you are sending an email, then you don't expect to have it at the same time, because all of that has delay. So it's usually acceptable for the business. And for event sourcing, that's especially important, because as Greg said, if we are modeling our system by events, then we are getting closer to the system behavior and to the business. So this is what Catering is responsible. So we need to put a wall between development team and the business, and especially between development team and real clients, because we wouldn't like them to talk to each other and solve those cases that I mentioned before. So we will go that by going with SAFe. It's named Agile Framework, so that's great. We will say that we are Agile, but we will put all possible obstacles, all formalities, and everything that we can to disrupt communication between the teams. So we will expect our business team to write everything on Jira. We will expect also development team to log everything on Jira. And we thought that, yeah, we should drop this event storming and event modeling stuff, because if we are doing that, then we are having the techniques that enable collaboration between business and also discovery of our business process, especially that during those workshops, development team and business people should work together. So that's something that, as I mentioned, we would like to avoid. But then we realized that if Catherine will be the moderator, and if we have a streaming team, then we can take the proper discovered business module and change it into the wrong technical model and technical implementation. So we decided that we will go with the event storming or event modeling, but we will just make it hard to understand how to translate that into the real life. So let's have a look on this example. On the left bottom, we have a transaction processing module. On the right side of it, we have configuration module, because we decided that we will complicate stuff and all the configuration from the different module will be centralized in this single module. And at the top, we have a notification module, invoicing module, and reporting module. And as you notice, transaction module has really detailed events. That sounds good, but we will ask all the other modules to listen for those tiny events that are understandable in the transaction module context. So notification module will need to listen for everything to notify about confirmed transaction, invoicing module the same, and reporting the same. So we will be having the leaking abstraction, and we will be going towards the distributed monolith. And also, we won't be sending any denormalized data, like, for example, transaction type name. So if any module would like to understand whether this was a withdrawal or whether this was inflow, then they would need to build a local cache of the transaction type, and they need to listen for the configuration module and then match all of those events together. So as you see, this is a mess, and we can even make it more mess because all the modules will be also listening to each other. Some notification module about some upcoming report, and the reporting about the invoices, etc. We could solve it by introducing external events or integration events, you name differently. So for example, payment confirmed event, because other modules usually are caring about the result, so the most important checkpoints of the business process. So we could solve it by that. Then this payment confirmed event will be bigger one, and it would contain all the events. But yeah, we won't do it because, as I mentioned, what's good is bad for us, and what's bad is good for us. So we will just ignore it. And we will keep our stream as long as possible. Why? Mikhail Shilkov did a nice thought experiment. Let's say that each operation, like a storing, appending event and reading event, we will count as the single IO operation. So this is showing like creating or appending event, one event per second, and this event will be appended each time to the new stream. So if we have like a really short streams with this one event, then we see that this is a linear growth of the IO operation during the time, which is fine because it's okay. But if we add like that we will be appending to the streams and have up to 10 events, then the number of IO operation will increase, because at first we will read 0 event if we appending the first event. If we appending the second, then we will read 1 event. If we append the third one, then we will read those 2 events before. And this grows for 100 events. You see, it's starting to grow exponentially. And if we have streams with 1,000 events, and 1,000 events is not so big. I saw bigger streams on our customers, and with that, our number of IO operation will grow exponentially. So, which is great, because that's what we would like to achieve. Because bad system should be sluggish, should be buggy, etc. And of course, if people tend to find some good solutions. And so we will try to move our development team towards snapshotting if they demand to make those streams shorter. So for example, each time we are getting in the cash register example, each time the cashier shift is started, then we will store a snapshot. So instead of loading all the events and all the transactions for the cash register. So for example, since we place it at the workstation, we will be only loading the transaction that happened for the specific shift. So we will load at first snapshot and then follow up events. But that doesn't sound so bad, but it appears that it is. See Roy's face? Because he knows what we are going for. So cache snapshots typically are aligned with the representation of our aggregate or our entity. And when the process is changing, or our understanding is changing, or business is changing, then snapshot structure tend to change a lot. So when we are changing the structure of our aggregate, we need to invalidate the snapshot, rebuild all of the state. For example, 100,000 of events might take ages, or we need to migrate them. And we all know how migrations are great, right? We could use the pattern that's named closing the books. It's from the accounting. So in the accounting, at the end, for example, of the accounting month, you are summing up all the transactions. You are creating the final balance and starting new month with the balance from the previous month. And the same case is, for example, for cashier registry. So as we have cashier shifts, then we normally don't care about the events from the previous shifts. We usually just care about the transaction that happened during the cashier shift, because we need to calculate whether the money that's in the cash registry is the same as we have in the system, etc. So we could have separate dedicated streams for that. And instead of having a gigantic stream, we would have a set of short living streams. But of course, if our developers will ask us whether we have a better idea than Snapshot, then we will say, well, I don't know, I haven't heard. We will also use other patterns, like a crowdsourcing. So instead of having the business meaningful events like transaction initiated, payment method selected, account balance updated, payment confirmed, then we will replace all of them with the transaction created, transaction updated, transaction deleted. Thanks to that, if we get, for example, transaction updated, then how do we know what was precisely changed? And that's confusion that we would like to achieve, because, reminder, we are building the worst event sourcing system. Next is the property sourcing. So instead of flattening our business process and our streams to the transaction updated, we will go the other way. So we will create a lot of tiny events, like user first name change, user email change, user last name change. And what's more, as I mentioned, we will ask all the other microservices to listen to that, to be able to build the local representation of our state. So this is an ex-ante pattern that we would like to use. However, as I mentioned, people in general tend to do good things. If they are put into the good environment, then they will be trying to make better. So we need to try harder. As Deming said, a bad system will beat a good person every time. So that's a system that we would like to create. And remember Michael? Michael will be responsible for that. So regarding Maurice and Roy, we will take really good specialists. Like Roy has 20 years experience in managing relational databases, in managing on-premise services. However, he doesn't have any knowledge about maintaining Event Store and about the cloud. And Maurice is great developer. He has serious experience in event streaming solutions and in relational databases, but he wasn't working, in fact, with event sourcing, because as we remember, event sourcing and event streaming are not the same. And this will help us to get the cliches, because when they will be looking at our system, so event sourcing system, then they will be looking at it with their past experience. So Roy will complain, well, in Oracle, we were doing that totally differently. So why we have to do it like that? On the other hand, Maurice, having the event streaming experience, will try to push the wrong understanding of event sourcing solution, and that will help us to just put them into tunnel thinking. And unfortunately, the good developers, they finally realize that what they are doing is not so great. So we need to have a mixture. We need to have a junior devs, like a solid principles policy, and we need to have Maurices and Roys, right? And we will also use fear, uncertainty, and doubt. This will be our critical managing techniques. So we won't be praising for good, but we will be punishing for bad. So people will be afraid to make mistakes. They will be afraid on making the initiatives. And we will, if that won't happen, then we will use Peter principle. And Peter principle is that when it said that we are getting higher into our company structure until we are reaching our maximum level of incompetence. So if we see that someone is doing too good, then we will put him into another position, like a manager. Won't they quit? I mean, we will keep them busy. In Poland, we have saying that you are running like with the empty beer barrel. And that means that you are doing a lot of useless stuff and not making any progress. So as you already noticed, we will be using wrong patterns, wrongly using our tools. And so they will be thinking that they are solving real and important cases, but they will be running just with the empty beer barrel. And we will pay them a lot. So as you know, Jordan will get us a lot of money. So they will be thinking twice before leaving. And we will let them to play with all the fancy technology stack. Because if they fail, then it's good for us. And the last technique that we would like to use came from Sweden. It's a 1973 year. And that technique is called a Stockholm syndrome. So we will be making our team work great, and they will be loving working with each other, but we will try to make their life misery in other ways. So on one hand, they won't be happy and they will be always complaining about the project, but on the other hand, the other things will keep them inside the project. So, it's not only technical solution or technical mistakes, because that can be solved somehow, but also that part is critical for building the worst event sourcing system. If nothing helps, then we will hire just a consultant, and consultant will just do the rest of the work. So if you didn't listen, then a quick summary. So it appears that to build the worst event sourcing system, we need to understand the difference between event sourcing, event streaming, and other patterns. So we need to, in fact, be building event sourcing system. And we might face some issues that if we tackle them separately, then might seem solvable, like eventual inconsistency in read models is acceptable. Idempotency, it can also be solved by various techniques. And events ordering can also be solved, right? But if we stack them together, then we would be just creating so much mess, especially if we don't know the right techniques, if we are using wrong tools for the wrong job, then this will be just a perfect mess. As I mentioned, we will be making our solution as complicated as possible. We will be ignoring the typical patterns, for example, strong consistency on the right model. So we won't be, we will be ignoring that we need to make decision based on the latest state, and we will be solving the technical bugs with the business process. So we will be just hacking. And we will also, our business model will reflect the worst system that's possible. So we'll be doing integration with incompatible technologies. We will be doing a lot of functionalities that doesn't make sense, and we will keep our business and development team separated. So because typically they could solve all of that by talking with each other, but that's something that we would like to avoid. And instead of using like the proper common sense like CAP theorem, we will be using CRAP theorem. So we will be ignoring the good architecture patterns, and we will be just doing the opposite. And then we will also incorporate all of the anti-patterns. So we will be creating distributed monolith, even though looking from the standing another point, this will look like, yeah, they are using microservices, they are using fancy technologies, but with the communication and wrong boundaries, we will be making that stuff harder and harder and harder. We will be using long-living streams to make our operation and our processing a time bomb that will hit us later on. And we will be doing also snapshots to just make things harder. And we will create a system that will be extremely hard to work for our people. So if your question is, shall I try to build the worst event sourcing system? Then my answer is, yeah, try us. but we will start in the next year, so we'll beat you again. So my advice is, let's start with the competition and contest for the best event sourcing system, because you will have much less competitors there. Thank you. That's all from me.